Here we have activity 1.11, part F. The function is g of y equals y. So, first thing we want to do is set up our difference quotient, which we've seen before, so I'm not going to go through that part. I'm just going to go ahead straight to setting it up. Limit as h approaches 0, square root of y plus h minus square root of y all over h. Now when you're dealing with a radical, a very nice technique to use is what's called multiplying by the conjugate. So I'm going to multiply by square root of y plus h plus square root of y all over the same thing, because I can't change what I have. Square root of y plus h plus square root of y. Okay, now here's what's so great about this. The numerator, when I go to multiply, that's as if that's in parentheses, I've got difference of squares. So let me write it out so you can see how this is going to play out. So I'm going to have square root of y plus h times square root of y plus h. So I have square root of y plus h times itself, so squared. Now my middle terms, I'm going to have a negative square root of y times y plus h. Okay, that came from right here. Here is the big reason we do this. We have positive square root of y times square root of y plus h. So those are going to end up canceling. Lastly, I've got a negative rad y times a positive rad y. That's going to be a negative rad y squared. And now, again, I'm not going to multiply out the denominator, kind of like in part E. Square root of y plus h plus square root of y, because I know there's going to be some simplifying I can do later, because my goal is to be able to plug in 0 for h. Right now I can't, because it makes the denominator 0. These cancel. That's very good for us. And also square root squared, so that's going to go away. So let's see what we get left with on top. Square root of y plus h squared is just y plus h. Square root of y squared is just y, so don't forget it's negative, so minus y. All over h times square root of y plus h minus square root of y. These y's cancel. I can now cancel an h from the numerator and denominator and end up with just a 1. So now I can plug in 0 for h in the denominator. So I'm going to take my limit, so I get 1 over. That h is going to become 0, so I'm going to end up with, that should be a plus, sorry, square root of y plus 0, so square root of y, plus square root of y, or 1 over 2 square root of y, and there I have my derivative.